Hey everyone, how's it going? It's Lee Halliday, and if you've watched any of my videos, you know I'm a huge fan of Next.js. It calls itself, like on their homepage, the React framework for production. And one of the things about deploying code to production, out there on the internet with real users clicking around, is that there's going to be errors, there's going to be performance issues that you need to track, deal with, and resolve so that they have the best experience. So we are going to work today with AppSignal, who's been awesome to partner with me on the last few videos I've done, to set up AppSignal, which is an error and performance monitoring tool, inside of our Next.js application. And in the process, we're going to learn about how to track web vitals that Next.js supports as of 9.4. And we're also going to see how to set up a custom server, set up an Apollo GraphQL endpoint within our Next.js app. So I hope you'll stick around with me. It's going to be a pretty cool episode where we'll be integrating it, deploying it, and taking it sort of from start to finish. So what I've done is I've used yarn create next app to set up a brand new Next.js application. And I've just gone ahead and I've added the different dependencies that we're going to use. And I won't go over all of them now, but things like Apollo, AppSignal itself, and Nexus schema, which we'll use to set up our GraphQL schema. And we'll learn what these are used for as we're building the application. So the first thing that we are going to do is we are going to create a custom server. So we'll just do server.js here. And this is where you can sort of take control over the incoming requests that Next.js sort of normally handles on its own. And unfortunately, what this means is that you won't be able to deploy to Vercel right now, but this will allow you to have a custom Express app running your Next.js application, and we're going to be deploying this code up to Heroku. So if I just take these imports so you don't have to see me write them out, paste them in. Okay, these are the imports we need to create a custom server, and right up at the top is where we have requiring AppSignal itself, locally from a file that does not yet exist. So we're going to create that. Just in here, create an src folder, and inside of that, we're going to create AppSignal server.js. We'll be using TypeScript for the rest of this video, but because the server and this file specifically run sort of right in our node environment directly, we're just going to do JS for these ones, and then for the rest, we'll do TypeScript. So within this file, the first thing that we need to do is import AppSignal. From equals, I'm so used to importing it from, this is the node way of importing code. So we're going to import AppSignal from Node.js. So the thing about this is that, yes, we're doing it in Next.js, but you could really use this Node.js Express tracking that I'm adding in any Express Node app that you would like to use it in. So from this, we'll create a new instance, lowercase AppSignal equals new AppSignal. And this is where we have to pass in the different environment variables and keys and whatnot to set up AppSignal to track things correctly. First, we're going to say active true, meaning actually track errors at all times. If you wanted to, here's where you could say like only do this in the production environment. But I actually do want to just start sending data up even when I'm developing. We'll give a name to this application so we can differentiate it. So this is called AppSignal Demo. And then we need to give it our API key. So here we're actually going to load it from an environment variable called AppSignal push API key. So with this in place, we can do one last thing. This will come later on, but we want to be able to tell AppSignal how to differentiate one deploy from another so that we can see if we've corrected an error once we deploy that to production. So for that, because I'm deploying this code to Heroku, I'm going to put Heroku slug commit, which is a way in Heroku to basically differentiate one deploy from another. And then we'll export this. So exports.appsignal is equal to AppSignal. So with this in place, we've basically figured out this first line of code that's importing an instance of AppSignal. So we have a number of other imports now. We've got some AppSignal Next.js specific imports, Express specific imports, and then we're importing Next and Express themselves. So from here on out in this file, it's a very typical Express app if you've ever worked in that before. So you could almost copy and paste it, not quite, but in a real Express app outside of Next.js. So we're going to set up our port first. So the way we're going to do that is we're going to see if there's a port environment variable. And if there's not, we'll just default to port 3000 that it will start on. We want to tell it if it's in dev mode or not. And the way you typically do that is by looking at an environment variable that's always set pretty much in any environment you deploy your code to, node env, and we'll check if that's equal to production. If it's not, we're in dev. So here we set up our app itself. Next, and we tell it whether we're in dev mode or not. So this is something from Next.js, and it's basically bootstrapping our Next.js application custom server. So with that app in place, we can call prepare on it. And then because it gives us a promise, so in the promise, we'll receive our, we'll pass it our function that will be called when this promise is resolved. Within here, we can set up our Express app to start listening to incoming requests. So Express works with middleware, and basically the request comes in and it passes the request from one function to a next, which is called middleware, that can sort of manipulate the request, intercept it, handle errors and things like that. So the first middleware we're going to use is Express middleware that comes from up here, AppSignal Express, and we need to pass in our instance of AppSignal that we set up. The next one that we want to use is going to be Get Web Vitals Handler, which will also receive the instance of AppSignal. Next, we want to add in the Get Request Handler. So if you're creating a custom server using Express in Next.js, you would normally have this Get Request Handler, except we're importing it this time from AppSignal Next.js so that we can start sending those stats up to AppSignal. So we pass it the app, and then a couple more, just bear with me. We've got Express Error Handler, so that if our request produces an error, we can track that bug and send it up. And finally, that's all the middlewares. So the last one is to listen. We tell it what port to listen on, and we have to pass a callback of what to do if it receives an error. So in our case, we're just going to rethrow it. So if an error, throw that error so someone else can catch it. And down here, we just give a little message, console.log, and we can tell the user we're ready on http:// localhost. And here you would put in whatever port the app was set up to run on. So this is our custom server. We don't have to edit this file anymore. And we'll get into a little bit more in the future about what this middleware here, Get Web Vitals Handler, does. But if you remember back to this AppSignal file, I used this AppSignal push API key. So we need to set up this environment variable. Otherwise, where's it going to get its value from? So the way we do that locally is we set up a file called .env.local. So git ignore, you can see, hopefully, yep. So this is an ignored file. You wouldn't want to commit this because you want to keep your secrets actually secret and not put them in your code. So AppSignal push API key. And why don't we also just set up, we won't have a Heroku slug locally, so we can just set this up to say something like local, so or dev, something like that, just so that it has a value. So we need to go get this AppSignal push key. So here's where we'll pop over to AppSignal, go to app, and I'm already signed up. And because they've partnered with me on this video, there's a deal. So basically the way AppSignal works, yes, it costs money like most error and performance monitoring tools do, but you can try it out free for a month. If you use the coupon code LEIGH, L-E-I-G-H, you'll get 10% off for your first year. So coming in here, we're going to say, set up a new organization. Oh no, I'm wrong. Scratch, add app. I've already got an organization. We're going to add an app to it. And here's where you sort of pick which language you're building it in. So they support Ruby on Rails, this is where I've had the most experience using AppSignal. It works awesome. And but the one we're working with today is Node.js. And we'll also touch later about JavaScript, which is the front-end code. So it tells you how to get going here, but really what we need is this key right here. So I'm going to copy and paste that and put it in my app. So with this in place, you'd think you could go and start your application now, but we need to make one final tweak so that it uses the custom server rather than the normal Next.js way of receiving the calls. So we're going to just tweak this dev call here. Instead of next dev, we're going to say node server.js to run this server file here that we created. And we're going to do the same for start. So node server.js. So both of these, now when we come here and we say yarn dev, it's going to run our node server code. It's going to load the environment variables that we put in the .env.local. And right now in a second, it will be ready to receive requests on port 3000. So I can pop this open and it's a regular Next.js application. It's just running within our custom Express server. So the next thing I want to do is start to tweak this over to use TypeScript. And we're going to start in a file within pages, called _app.js. So what is _app.js? This is sort of the parent component of every single page in a Next.js application. So it receives, say for example, the home page, index.js, and it wraps itself around that. It receives this page, which is called component here, and this allows you to wrap providers and different things around this. But this is also the place where we're going to put a function that we're going to export that will report web vitals back to our server. So first things first, let's create this into a TSX file, just like this. And I'm actually going to stop this, restart it, and it's actually going to detect that we're trying to use TypeScript. So it's going to tell me, hey, go add TypeScript itself and some types for React, and we'll restart it again. It's now going to have all the packages it needs, so it's created us a tsconfig.json file, which is great. So in this tsconfig, I'm going to do one little tweak. I'm going to just tell it where the base URL is, and I'll talk about why I'm doing that a little bit later, but it helps me sort of deal with some nested file structures and things like that to make it easier to find the files that we're working with. So we'll close this. We'll just restart our app one last time because we tweaked that base URL. And that's as easy as it is to get up and running using TypeScript in Next.js. This file is already valid TypeScript, but what we can do now is we can come in here and we can export a function called report web vitals, which receives a metric, and then we have to do something with that metric. So if you want to just see what it is, we can add a console.log, come into our inspect, and these objects here. So what Next.js does is it starts reporting different things like, here we have Next.js hydration, here we have web vital FCP, web vital TTFB. So what are all of these things? So Next.js 9.4, they came out with support for integrated web vitals reporting. Web vitals is something the Google Chrome team introduced, and it's used in Lighthouse reports. But basically it tells you how responsive your web application is. So it reports on things like the largest contentful paint, how long it took to render the screen, how long it took to allow for input delay, cumulative shift layout. You know when the page loads and you go to click a link, but they've inserted an ad before you could click the browser and now you're on the ad? That's sort of tracking how much the page is shifting around. So it allows us to receive metrics about that. If you click into their docs, it shows you sort of how to set up and report this information to the server. So I'm just going to copy and paste this, and then we'll go through it line by line and we'll tweak it slightly. So instead of console.logging, I'm just going to paste in. So what we got, first we're JSON stringifying this metric that we were just looking in the console.log. And then where are we going to send this metrics? So we're actually going to send it to our own custom server that we just set up to an endpoint called __AppSignal-web-vitals. So this is important. And the reason it's important is because over here in server, when we added this middleware get web vitals handler, this middleware is looking for a request to that endpoint so it can intercept it and report that information back up to AppSignal. So then what it's going to do is it's going to check, does it have this send beacon? And if it has send beacon, it can use that to send the information to our URL. Otherwise, it will fall back to fetch, where it will post this information up to this same endpoint that we set up here. So why don't we reload the page? And we should have the no more console.log here's anymore. And now what we can do is come back, and it's actually detected that as I've been refreshing the page and whatnot, it's been receiving signal from my app. So it knows that we're ready to go. So we can go to the app, and you can already see in sort of this AppSignal dashboard here that we've got throughput. It's obviously not a lot because it's me locally, right? But we've got throughput. We can see requests coming in. We can see how long it's taking to respond. So 300 milliseconds, 400, 243, etc. And if we refresh a couple times just to send some more data up, perfect. So it's detected the website, the Web Vitals reporting that we've been sending up via that code we just looked at. And it's automatically added a new dashboard that's going to tell us about how our app's doing in terms of these Web Vitals signals. So it's doing one column by default. We can switch to two. We don't have too much data yet, obviously, because it's just me locally. But we'll come back in a sec and, oh, right away. So there we go. So it's telling us time to first byte, 28 milliseconds. Here it's telling us, if we just get the end, 1 hour. So 890 milliseconds for our first contentful paint, largest contentful paint, etc. So back here it tells you what you should be looking for. So for example, good is under 2.5 seconds. First input delay is 100 milliseconds. Cumulative layout shift is 0.1. So those are the sorts of numbers you'd want to be looking for. It obviously is a lot better when you're in production environment and you have real users, a lot more than me just clicking around. But now we're at least getting reports about that. We can also go into performance, and it's telling us about the different requests that our application's receiving. So it knows that we're receiving requests to the homepage /get requests, and it's telling me that it's taking 9 milliseconds for Express to render. Over here on the right, we can see other requests, so you can maybe pick a slower one and try to figure out what's going wrong. And we'll look in here in a little bit. As we add more features to this, like Apollo, it will start to tell us like how much Apollo took in relation to the whole request. If you had database in here, like a Postgres connection, it would start to tell you what queries are being run and how long each SQL statement is taking. So you can find your slow requests, troubleshoot what's causing them to be slow, and better user experience if you can make those requests faster. So why don't we just start to add more features to our application? We'll click back to our code. So next up, we're going to add Apollo, both server and client, to this application. So we're just going to close all of this out. We're going to go inside of our API pages, which were run on the server, and we're going to just rename this to GraphQL.TypeScript, because we're going to be doing this in TypeScript. So we're going to delete everything here and just start from scratch building this out. So the first thing we're going to import is the Apollo instance that we set up, or sorry, the AppSignal instance that we set up so that we can report on performance metrics about each of our GraphQL requests. So this is coming from, import AppSignal from src AppSignal server. Perfect. So the reason I can do just without a dot here is because I set up that base URL dot here so that it knows where to look for our files. So with that in place, we can start importing the things that we need to set up our GraphQL endpoint. First thing we're going to import is create Apollo plugin from AppSignal Apollo server. So this is used to specifically report on Apollo GraphQL requests that we're receiving up to AppSignal so we can know how long each of those is taking to process. Now we're going to import our Apollo server itself from Apollo server micro. Micro is the Next.js specific version that you want to use to set this up. Next, we're going to import make schema and query type from Nexus schema, which is a code first way to declare a GraphQL schema using TypeScript, and it's my preferred way to set that up right now. And we're going to import path from path. So in GraphQL, you've got your root nodes, which are the top level query and mutation that you can perform. So that's what we're going to set up first. So our query type will have a definition where we define which fields that we want to add on the top level. So we're going to add a string field called name, and it's going to just resolve to my name. And we're also going to add something called a website, and we'll just point it to my website, leehalliday.com. So with this query in place, we now need to tell Nexus about all of the different types that we have. So what we're going to do is create a schema, which will be make schema. And in here, you have to pass it what types your GraphQL schema has. So we only have one right now called query, so we'll add that in. And it's missing some things. So if we highlight, it's not assignable, object literal, you missed schema config. What did I do wrong? Let's just keep going and hopefully, oh, it's because it's types. There we go. Okay, so with types in there, we're going to just do one thing that will help Nexus configure itself properly when it's dealing with TypeScript. So we're going to tell it where to put the outputs that it's auto-generating. So it auto-generates two things. It auto-generates the GraphQL schema itself. So we'll tell it where to put it. We're going to tell it to put it where the process is currently running, so its current working directory, and we'll put it in a file called schema.graphql. We'll also tell it where to output the types that it's going to be generating. So we're either going to put this in process.currentWorkingDirectory, in src, in generated. Why don't we go create that? Perfect. And then within something called Nexus.ts. Cool. So Nexus should be happy. We can take this schema that we produced and we can now finally create an instance of our Apollo server. So we'll just say const server is equal to a new Apollo server. So we need to tell it what schema we're going to be using. And in order to track things correctly with AppSignal, we want to use the plugin that we imported. So plugins will tell it to use create Apollo plugin, and we have to pass it the instance of AppSignal so that it can send the data back up to our AppSignal. So with the server, we now create a handler. And the handler is what actually receives the incoming requests, and it passes those on to the server. But we need to tell it where to listen to requests on, what path is it using. So the path for this is /API/GraphQL because that's where we set up this page here. So the last thing you need to do, this always trips me up and it won't work correctly if you don't do this line. So make sure you do it, is you need to export some config and you need to tell API request to not parse the body. Typically, bodies are parsed, like it parses the JSON and converts the string JSON to an object. We don't want it to do that in this case because Apollo should handle everything for us. So we'll just say body parser false. We export our handler. And with this, we've created from scratch an GraphQL server. So what we can do now is head on to the client. We can actually head over to API GraphQL. We'll just get rid of whatever query I had before. So we'll show here, demo query. What are we going to query? We're going to query the name and the website. And see how as I type it, it's popping itself up. It's because it knows what the schema is. We can click over here to schema, see that, see the docs for it, what we have. So we've got a GraphQL server running. Now let's hook it up to the front end. So we'll just go back to the home page here. So for GraphQL to work on the front end in Apollo, you need to create an instance of the Apollo client. We're going to put that in src here, Apollo client.ts, and we just need to import the things that we normally import. There's nothing specific about AppSignal here. This is just how you set up a simple Apollo client. So we're going to import a few things from Apollo client, and what we want are in-memory cache, Apollo client itself, HTTP link, which is how it makes requests to the backend, and this thing called normalized cache object that will help us with TypeScript. We are going to define an instance of the Apollo client out here, and we just need to set up the types correctly so TypeScript's happy. So this is going to be a type of Apollo client, which will receive a normalized cache object. So we haven't actually created an Apollo client yet. We will do that later in this function here called create Apollo client, like this. So this will always return us a new instance of the Apollo client. And Apollo client wants to receive two things. It wants to know what the link is, how it's going to make these requests back to the server. So this will use a new HTTP link, which will point it to the same API page that we set up, so /API/GraphQL. And we also need to tell it how to store its cached contents. So if it makes a query, it stores that in its cache. So if you make the same query, it can just reuse the cache. And we are going to use this in-memory cache that we created. And the last thing and the function that we're actually going to export from this file is a function called, so export function useApollo. So what useApollo will do is it will look at this Apollo client and it will assign to it either the Apollo client if there's already something assigned there, double question mark, which is basically like, I think it's called nullish coalescing operator. Try the left side first. If it's nullish, go to the right side. So if it's nullish, we're going to create our new instance of the Apollo client, and then we're just going to return the Apollo client instance that we set up or reused here. So with our Apollo client set up, we can now go into our _app that wraps everything inside of our application. And we need to wrap the Apollo provider around every page that we're using. So here we can import Apollo provider from Apollo client. And we also need to import our useApollo function that we just created from src Apollo client. So with these two things in place, what we can do is we can say our client is equal to useApollo. And what we do is we pass that client to our Apollo provider, which is going to wrap every page of our application. It's complaining because it needs client property. So this will get our instance of the Apollo provider. And with that in place, we can now make actual GraphQL queries on the front end. So we're going to pop over to our home page. Why don't we convert this to TypeScript? Done. And we're just going to delete most of the HTML that comes with Next.js just to make this simpler. Cool, we can leave that, why not? So to make an actual query on the front end, what we need to do is import a hook called useQuery from Apollo client and GQL. So the first thing we need is to define our actual GraphQL query. So const home query is equal to GQL. Here's where we paste in our actual query. So query home query is going to ask for the name and the website, like this. So with our home query set up, we can come and use it within our component. So const data and loading is equal to useQuery. Here's the query we're going to run. So why don't we just say if there's not data or it's loading, we'll just return a span that says loading, ... of course. And if we get to this point here, that means we've got data to deal with. So why don't we just put it inside of our div in a pre? And what we can do, here's a little trick. This is, it's an object, JavaScript object, so we can stringify it. Oops, embed this. Stringify the data, but space it with 2 spaces on each line so that it looks nice and prettified. So if we go to our home page now, you can see that we are making a front-end request querying GraphQL to our GraphQL server that we just set up, and we're able to see the data that we set up here. So we'll just make a few requests, start sending some data back. And now we can pop in, and we should have a little bit more data here in our AppSignal dashboard. But we can click into performance, and now we're getting a lot more information. Remember that demo query that I ran before? We can actually click into that, and now we can see in our request how long it took to receive and process that HTTP request, but how long in that request did it take to process the GraphQL query. So it only took 2 milliseconds. We can come down and we can actually hover this execute.graphql, and here we can see what the query that ran actually was. And this is useful because let's say you've got queries that are mostly fast, but then for some reason one query is slow. You can pop it open, see what fields it's asking for, and here's where you can go in and troubleshoot. Well, maybe it's taking a long time to grab the website from the database, or maybe name, etc. So it helps you troubleshoot and speed up things for your users. So that's it for that section. Next section we're going to move to is basically how to set up bug and error tracking on the front end. To set up error tracking on the front end with AppSignal, we're going to pop in here into App Settings. And we're going to scroll down to Push and Deploy. So there's a separate key to use for front-end error monitoring. And we are going to copy that. And we're going to go into our .env.local, and we're going to set up an additional environment key here called next public AppSignal frontend key. So why does it begin with next public? That's because Next.js automatically will expose this environment variable in the Webpack build to the client. That's required because we actually need this secret in the client, otherwise it won't be able to send errors back to AppSignal. And with that in place, we're going to quickly set up an AppSignal client.ts instance. So this is very similar to the server one that we set up. So we'll import AppSignal from AppSignal JavaScript, which is the package you use for front end. And here we're going to export our instance of AppSignal, which will be a new instance of this. And we need to give it the key that we just set up. So process.env. Next public AppSignal frontend key. And so that it knows which version of the code that produced this error was, we're going to use that process.env.heroku slug commit right here. So our instance of our client instance of AppSignal set up. Now what we can do is go into our underscore app, and here we need to wrap another component around our entire application called an error boundary that's basically going to trap errors and send that information back to AppSignal. So we'll import that here, import error boundary from AppSignal React, because this is specific to React code. So the error boundary will wrap itself around everything. And with this error boundary, we need to give it the instance of Apollo that we're using. So instance, sorry, not Apollo, AppSignal. Too many things with app at the beginning. So we need to import that instance here because we haven't yet. So import AppSignal from src AppSignal client. So it's happy. And if we want to, we can give it a fallback. Basically, if it captures an error, what should it render? So we can pass a function here that will receive the error if we wanted to display it. And in here, we can just say boundary error caught, like that. So you can change this to be nice looking. For now, we'll just do that. And with this in place, we've already set up front-end error tracking. So why don't we go produce a couple errors so that we can start to see that coming in. I'm going to restart the app because I changed the environment variables. So that will do its thing. And we need to create a bug. So why don't we add a button, error, and on click, what we'll do is produce an error. So there's sort of two ways that we can send data up to errors that we catch up to AppSignal. The first is that we can actually handle and catch the error and then sort of choose ourselves to send that error up to AppSignal. So the way you do that is, why don't we first try, and we'll throw a new error. Throw in this guy like that, and we'll catch it. So we'll catch the error. And then in here, we can send it up to AppSignal. So we need to import our instance of AppSignal from src AppSignal client, like this. And then we can say, hey, AppSignal, here is an error. I just caught it and I'm passing it up to you. So that's the first way to send an error up to AppSignal. The second one, we'll actually create a new file for this, and we'll call it boundary.tsx. Is basically when the boundary catches the error because nothing else caught it. So in here, we're going to import useEffect from React. We'll export our component, so export default function boundary. And in here, we will return, let's just do a div that says hello. And we want to trigger an error in here somehow. So let's say within our useEffect, an error occurs. So useEffect runs after the current render. So it will render this once. This useEffect only runs once ever because I used empty brackets here. But what we can do is throw a new error. Throw new error in boundary, like this. So now we have two different types of errors, one that's not caught and one on the home page that's caught when I click the button. So if I come back to our app, we should have a button now. There we go, error. So this is the first one. So I'm clicking it. Nothing bad is happening because I was catching that error, and but hopefully it's sending that error up to AppSignal. The other one was in boundary, where you can see here, in local dev environment, Next.js gives you this nice error pop-up so you can troubleshoot it. But behind this thing, you can actually see boundary error caught. So this was the fallback that we set up in the error boundary from AppSignal that will catch this. So let's just produce a couple errors here as well. And if we go back here and click into errors, we can start to see the errors that are coming from our front end. And it would actually be emailing me as well. If I set up Slack, it would be sending me information on Slack as well. So we can come in here and we can see that this was the in-boundary error. It happened in Canada where I am. It happened on this user agent in React. And it shows you where in the code that this error took place so that you can troubleshoot it and figure out what went wrong. In boundary. So these were the in boundary errors. Here's the throw in this guy error. So they're both coming under the same error, and that's just because when I was throwing the error, I threw it as an instance of error. So if there were different types of errors, it would show up as different items. We are going to deploy this application to Heroku. So first things first, we're just going to commit this code. So git add, commit this demo. Oh no, whenever you do exclamation points, things go crazy. Okay, so we've committed it. We're going to go over to my GitHub, create a new repository for the AppSignal demo is available. So we'll create that, copy, push from an existing repository. So now we have this code up on GitHub. Perfect. And the next thing we want to do is create a new application in Heroku so we can push this code up to Heroku. So clicking over to Heroku, and again, you could deploy this anywhere you want. I'm just using Heroku because it's super easy and free. So we're going to create a new application. We'll call it the AppSignal demo. In US is fine. And then what we can do is it tells us how to deploy this. So basically, this code right here, Heroku get remote AppSignal demo. So pasting this in, it now has Heroku set up as an external Git repository we could push to. So we could say git push Heroku. And that would deploy our code up for the first time to Heroku. So while this is building, we're actually going to come back and we need to make one tweak to be able to expose an environment variable to our front end that we need. Remember in the AppSignal client, we're using this Heroku slug commit. This, even if it's an environment variable, won't be exposed yet because it doesn't begin with next_public. But we can go and make that happen by creating a file called next.config.js. And what we can do here is export an object that has env, and we can basically tell it what environment variables we want to use. So Heroku slug commit, and this will come from process.env.heroku slug commit. So this is it. If we wanted to create source maps, for example, we could do that by, why don't I just go over to a new tab here, and I'm just going to quickly add Zeit next source maps. Perfect. And what this will do is when errors occur, instead of showing you like the Webpack crazy version, it will show you where it points, where the error occurred in your actual like TypeScript code or whatnot. So the way you use that is you say const with source maps is coming from Zeit next source maps. And basically we just take this, which is a function, and wrap this around that object we were exporting. So we've done two things here. We've added source maps to our Next.js application, and we've exposed Heroku slug commit. Heroku doesn't have this automatically. There's one sort of little thing that we need to add to make that work. So we need to enable this functionality. Heroku labs enable runtime dyno metadata. So now whenever we deploy, it will have that Heroku slug commit available as an environment variable. So remember, we need to set up the other environment variables that we need for this to work. So first things first, we are going to go back to AppSignal and we are going to create a new application again. We're going to do it for Node.js and we're just going to copy this. So we need to go and add this environment variable to our hosting environment, Heroku. So we go into settings, we come in here, we can paste that in as a value. And what did it need to be called? This one was the AppSignal push key. So paste that in, add. And what I'm going to do is I'm just going to commit the changes. So what did we change? We added source maps, and then we added the next config file. So git add commit, adding source maps and exposing env-var. We'll push that up to Heroku again, and it will deploy and do its thing. So our deploy has finished. We can now open that. And if all went well, beautiful. We've deployed to production our Next.js application. We're getting our data here from the backend. One thing they do is, remember that API GraphQL? It knows not to expose this playground on production automatically. That's something from Apollo server, which is great. And if we come back to AppSignal and we go to our app, so it now detected that we've got AppSignal demo in two environments, our development environment and our production environment. And it will start to receive data shortly about that. And what I can do now is just go down and get that front end key again. So this front end key here. And we can add that to Heroku. And it was called Next Public AppSignal front end key. Perfect. So we just need to deploy one last time for it to pick up this key. And now we'll be receiving both production performance and error tracking on the server, but also errors that are produced on the client in the browser. So why don't we trigger that? We just need to change one file. AppSignal demo. Let's commit this README. Adjusting README. Push that up. So it's going to do its thing and deploy to Heroku again one last time. Push it to Heroku. So now we can open our application and it should still work. We can produce some errors. We can go to our page boundary, which is catching the error, and it's not displaying that Next.js message anymore. It's just saying boundary error caught. And so coming back here, we should start to be receiving some data about these requests, about our web vitals. Let's see if the errors came in yet. So they haven't arrived yet, but sometimes it just takes a second, then they'll show up. And that's basically how you set up Next.js with AppSignal, with server-side error and performance handling, with client-side handling of errors, with web vital reporting, with Apollo. We did it all. It was a long video. If you're still here, thank you so much. Thanks again to AppSignal for partnering with me on this video. Hope you have a great day.